So this question says the first three terms of a geometric series are k plus 12, k, and 2k minus 32 respectively, where k is a positive constant. And part A says show that k squared minus 8k plus 384 equals 0. So the first thing to notice here is that first of all it says it's a geometric series. That means that there's a common ratio. In other words, if you times the first term by r, you get k. If you times the next k by r, you get the next term, and so on. That means that to get r, you could divide k by k plus 12, and that will give you r. Or you could do 2k minus 32 divided by k, and that would also be r, because it's called a common ratio. So let's do that. So let's divide the second term by the first term. So second term by the first term, and that would be r, because that's, if you times by r, if you divide the second term by the first term, you'd get r. And let's divide the third term by the second term. So we divide 2k minus 32 by k. So both of these expressions are equal to r, the common ratio. So we can put them equal to each other. So let's cross multiply and work out what it would be. So let's cross multiply and you'd get k squared equals bracket 2k minus 32 close brackets k plus 12. So we've got this. Now let's expand it and bring it all over to one side. So if we do that, we're going to get that k squared equals 2k squared minus 8k plus 384. And if we take k off both sides, we'll get 0 equals k squared minus 8k plus 384. So we've proved what we need to prove, so QED. Okay, part B. Hence show that k equals 24. So let's factorize this and solve it. So that was part A. We're now doing part B. So we're going to factorize this, so let's factorize it. That equals 0. Now we know that it's k and k at the front of each bracket. And I'm going to cheat a little bit here because it says show that k is equal to 24. I'm just going to put a 24 here because I know that it's going to have to be a 24. And if I do 384 divided by my 24, I get 16. So I've cheated there, but why not? And the question says, let's just check the signs. So we want a minus 8 there. So we're going to have minus 24 and plus 16. So we've factorized it. And let's then find out what then k would be. So k would either be equal to 24 or k would be equal to minus 16. Now it says the k is a positive constant, so that rules out that solution. So therefore we've shown that k equals 24. Okay, let's then do part B or C. So part C says find the common ratio. So we know that k is equal to 24. Let's work out what each term is. So the first term is k plus 12. So k plus 12 is 24 plus 12. So the first term is 36. The second term is equal to k, and that's just 24. And the final term is 2k minus 32. Well, 2 times 24 is 48. Take away the 32 is 16. So we've got our first three terms of the series. So let's divide and get the common ratio. So let's divide the second term by the first term. Well, that's then going to mean that r, the common ratio, is 24 over 36. Or if you cancel that down, 2/3. So the common ratio is 2/3. And finally, part D. Part D says find the sum to infinity. So the sum to infinity is equal to a over 1 minus r. So that means that a, which is 36, over 1 minus r, that's 1 minus 2/3. And if we do that, we're going to get that that's 36 over 1/3. And 36 over 1/3 is equal to 108. That's it. So the sum to infinity would be 108.